Today's episode is called Function Calling. The calling half is a solved protocol. The interface half has three things, and they decide whether your agent works or not. So let's say we have a scenario. This scenario we have Anthropic shipping a web search tool. So this is basically how we're going to represent it. And you have a standard definition, a name, as you can see here, description, current information, input schema, and the model sends your query. Basically, query for third quartile, earnings from 2025, whatever query you need. So here it appended the year to every query. If you ask about 2023, it will answer you about 2023 and 2025. It will, whatever year you're gonna append to it, it's gonna search for a different year, to a different year, of course. The issue is that if, let's say, you get nothing relevant here, you might think, okay, the model is not working, and while the truth is that it's actually not the model that's not working, it's actually the tool that is being used by the model. And the fix for that, as I said, is not a new model, no new training, no prompt engineering. You just need to rewrite the tool's description. So this is basically the episode. You have the calling half of the function calling, which is solved, standardized, documented. You have the same protocols. You have basically, when it comes to APIs, we're just gonna have the same, very similar APIs. So REST is very well documented on that side, and models know how to use REST. But the interface half, the naming, the description, the schema, how to write those, is the unsolved part. And this is what I'm trying to teach in this episode. The part that is less taught in schools. This is actually from this article from Anthropic. Check it out if you want to have more details after the episode. First of all, we're gonna kill the vocabulary confusion, because OpenAI, Anthropic, Google have different names for the same thing. Like OpenAI would call it function calling in their documents, Anthropic would call it tool use, and like Google would call it the same way OpenAI calls it. It's basically all function calling if you see tool use from Anthropic, because mostly I think Anthropic releases the most developer guides and like data about this stuff. It's all function calling basically. So you have 4 steps. You send a tools array. We will see how that looks like concretely. Each tool has a name, a description, and a JSON format. The model returns a call, as you see here, a tool name plus JSON arguments, and then you execute it. After that, you return the result, and the model continues with the result in its context. So here, let's say you have your context, and it goes like this in your context. So very simple. But there is a part that everyone, maybe from outside the industry, gets wrong, is that the model does not execute these tools automatically. You must run each requested action and return a tool result to Claude. We will see what is a tool result. That's coming up in the next slides. So the model does not call your function. It cannot call your function. It has no network, no shell, no runtime. You need to figure out how to do that. So it emits a request, and that is its entire power. And it's the reason every control we discussed today lives on your side of the line. It can emit that request because it was trained on this exact syntax. So you need to train it on the syntax, which is not really, you're not really training it. You need to use the syntax which was trained on by Anthropic and OpenAI. Of course, I guess the other open weights models use the same syntax, but here I'm just gonna cover OpenAI and Anthropic because they are the market leaders. And your tools array is injected into the prompts and billed as input tokens. So that's another thing. Tool use is not free. So be careful, of course, if you're using your tools. So basically how this looks like, if this is how Anthropic does it. So the model emits a tool use block with an ID. So this is our ID. It has a name, it has the input, and you run it and send back the following. you get your tool result block, which is carrying the same ID, and the content. And the idea is that with the IDs, you're going to pair up the tool use and the tool result. Now for OpenAI, it's the same thing, but a bit different. So the response comes back with finish recent tool calls. And what this means is basically it says stop generating. I want to use a tool, and something, and actually a tool calls array. It gives you also tool calls array like this. It's a block with the function and name of, and it's an argument. So here you have the name and the arguments. One thing, the argument is a JSON string, so it's not an object here. It's not the same as here. And you have to parse it. So to get this, you have to parse the JSON string to know that it's okay. It's PO number 4471. So that's one of the bugs that you might have early on. But the response looks more or less the same thing. And to give you a map, like for the rest of your career, tool use, which is this, is more or less like tool calls. Tool result, like this one, is basically like the role tool. So it's basically the same protocol, but two dialects of the same thing. They're trying to represent the same thing. Why didn't they use the same one? I don't know. They just like to make stuff different and difficult, I guess. So one thing to realize from here is that the model never saw your function. It saw a name, a schema, and it wrote back a name and some JSON back. So it never saw your code. It just saw data. It's basically like a database or a server. You're just launching your requests. So you actually can control the decision calling instead of the model. You have different, so it's a parameter and it has different settings. You have four main ones. There is auto, which is the default one, which means 0 or 1, like 0 to many, basically. And the idea here is that it's the model that will choose how many will decide for you in this decision. After that, so for these two options, required is what, or forced function is what OpenAI calls it. Any or tool is what Anthropic calls it. So for required or any, it says it must call something. So minimum, so basically it's one to many. Forced function or tool, this says, okay, and you need to send with it the parameter or the tool name, which says, okay, you must call this tool, call exactly one specific function, and none, you're just basically calling nothing. So actually there are two other parameters worth knowing. Allow tool, which narrows the callable set without breaking prompt caching. We will talk about that in the next series. And disable parallel tools, which caps the turn at a single call. So to go into more details, I will have a full series that discusses all of this. The idea of this episode is more like a general oversight over function calling. One mistake people make often is that they would reach for required in every case, which is a very bad instinct. This is a very beginner instinct because tool calling brings costs and brings many problems, and we will discuss these problems in depth in the upcoming slides and upcoming episodes. So actually I wanted to give you an example, and this is coming from early models. In the newer models, this has been solved. So here you need to know your capabilities of your, like, whatever models you're using. So let's say this will be the request you're sending. The user is saying thanks, that is all. And your tools they say read PO and post to ERP. Tool choice, on the other hand, it says tool choice as required. Now there is an issue here because no tool will fit this message. You do not, like, the model will not find a tool to use here. But required just deleted the only correct option, which was just calling nothing, right? So what it comes back, and what these models, especially the ones that will be cheaper, they will literally hallucinate an answer. So, for example, here, you would get an input, and it would literally create a PO number. And this happens, actually, this research, they proved that models really early models really struggle to answer with an error or not finding an answer. And one of the things that happened was they would, for example, create a name just to fill all of the empty fields, which is a very big problem for your data, of course. So what the model does is that if it must produce a tool call, so it fabricates or leaves blank in the arguments, and there is no way for it to signal no tool applies. So here I need you to read the dial honestly. What does that mean? Is that required is not try harder. Required is a promise. It's like a constraint you're giving to your model, and you're making that a tool always applies at this point in your flow. If your router cannot guarantee that, leave it on auto and let zero calls be an answer. One interaction, and this is the reason why I want you to be careful about this information, is that the newer models, for example, you have manual extended thinking, or the newer models will force an error, and you just, like, this incompatibility is not really a universal rule. It is version specific to the model you're using. So here I need you to be careful. You really need to read the documentation of your models and know what you're using. So this is actually coming from the document from Anthropic. For example, I know that Fable and Opus 5 actually will tell you that you're making a mistake. Opus 2 will tell you that you're making a mistake. Or like if you're requiring tool usage, they will sometimes just tell you, no, I'm not gonna do tool usage here. Earlier ones, I'm not sure, to be honest. I will need to check the documentation, but basically, yeah, you need to double check your information before using any tool in production. So now the calling side actually got a huge win in 2024, and it was these two flags. Because the model, usually you would just send a request and the model usually matched it, sometimes not, and that created problems, right? But one flag changed that, and it was strict. Here you just say true in the function definition, plus additional properties you say false. I will show you how that works more or less. But verbatim, what it bought is that, like, what it did is that structured outputs would come via tools would be available. Like your model would create structured outputs, basically JSONs, as output. And this is coming from OpenAI. So before these two flags, with the version of ChatGPT-4, it used to answer, like, conform to the modality less than 40%. If they trained the model, it would work at 93% with the flag, constraint decoding, a perfect 100%. Actually, this is the best argument for process mining. I know this is something many people laugh at me because I always insist on process mining when agentic AI people meet me. But if you want really enterprise AI, I really believe process mining could be the way. So, and here the mechanism matters because it's not better training doing the last 7 points, it's the decoder. The quote from the research is that we convert the supplied JSON schema into context-free grammar. At every token, the sampler is restricted to tokens that the grammar is allowing. So a token that would violate your schema is not merely unlikely, it is unsamplable. This is why the number is exactly 100 and not 99 or 93%. Here, there is actually some restrictions. First of all, it supports only a subset of JSON schemas. The first call with a new schema is slower because the grammar gets compiled and cached, and it is not compatible with parallel function calls, which we come back to. Anthropic shipped the same capability. Anthropic shipped JSON outputs and stricter tool use in public beta in November 2025. Now moving to general availability soon. Gemini shipped the same thing, and they called it response schemas. So it's basically they are all shipping the same thing, and it's all coming from this flag. So strict mode actually solved one thing completely and another thing not at all. Here we're gonna do divide. On the left you have well-formedness. So the JSON parses required fields are present, which is great. No invented fields, types are correct, and this is guaranteed by the grammar. On the right, you have the correctness. So is this the right tool? Is that the right purchase order? Is the amount in cents or in euros? Should it have called anything at all? And this is guaranteed by nothing, and this is creating problems. Actually, there is a solution for this, but we will talk about this in depth in the next series. Concretely, this call is perfectly valid. So this is an example. Against the schema, the PO number has 2 digits transposed. The amount is in cents, as you can see here, where the tool expects euros, for example. It parses, it validates, it posts, but it's still wrong. This will create catastrophe if it's posted to your ERP. You might be paying 10 to the power 3, like 1,000 times more for something. And so unstructured outputs does not prevent all kinds of model mistakes. The model may still make mistakes within the value of the JSON object. This is actually code from OpenAI. So strict mode moved the failure, basically. It did not remove it. Your arguments now always parse, and they can still be completely wrong. The steerability research lands in the same place. Steering can change which tool gets you called, but not what value gets passed to it. So there is a live argument about whether forcing a format makes model worse at thinking, and you should know about both of these sides before writing anything. So in the same 2024 paper, I believe it was the same one. Well, I might be wrong here, but whatever it is, the title of the paper is called "Let Me Speak Freely." And the idea here, what they said is that we observe a significant decline in LLM's reasoning abilities under format restrictions. These are the figures. You have the free-form reasoning under strict format constraints. And you had 10 to 30% degradation report. This was from EMNLP 2024 industry track. Now, there were 2 rebuttals to this measurement. First of all, critics argued the study conflated true constraint decoding with weakly prompted JSON mode, so which are 2 different things. The authors, when they did the reruns, note that the JSON mode actually beat unstructured generation, so which just kills their argument, and that zero-shot chain of thought closed much of the gap. And the underlying cause is more interesting than either of the headlines. So this is the whole idea of what I'm trying to explain here. So a JSON schema can force the answer field to come first, which makes the model commit before it has finished reasoning, which of course can cause problems because the model is already writing its answer before it finished reasoning. So the honest verdict is not that structure is bad, it's that the order in which your model is executing or reasoning matters. So let the model reason first and emit the structured call last, which, notice, is exactly how a reasoning model already behaves. Think, then call. If you put the answer field at the top of your schema, you are fighting your own model for the answer and it's creating these degradation reports. So at the end of the day, I will be also, again, series 2, I will explain how to figure out this order, series 2. So since Dev Day in November 2023, one model can carry several tool calls at once. And here, the purchase order and the goods receipt are being read at the same time. So both are reads, they do not depend on each other, so firing them together saves you a whole round trip. It's a good idea. And the controls are one line. So basically, this is the parameters you need to write. This one is, I believe, this one is for OpenAI and this one for Anthropic. And here the catch, and this is documented from, I believe, from OpenAI, they say structured outputs is not compatible with parallel function calls. When a parallel function call is generated, it may not match supplied schemas. That's a big problem. If you read it twice, you need to understand that you get strict. You either get strict or you get parallel. You can't get both at the same time. So this is XOR relationship. So it's also measurably harder for the model. On the benchmark categories, single calls sit at 99, while parallel multiple sits at 80. And that is an older model, so take the direction rather than the magnitude. So maybe newer models might get better results here, but still, there is still a degradation. And here we have actually, which gives us a rule, parallel reads, but we use serialized writes. This actually is the same idea we found when we were deciding the architecture for our agents. So two reads cannot corrupt each other when you have that serialized. So two writes or write, racing a read can pay the same invoice twice, of course, if you have two writes that are happening at the same time. This is like banking. This is the same issue you'd find at banking, for example. Here, one thing I would say is that this read-write rule is actually mine. So it's grounded, for example, from something that I'm seeing in my current job. It's not really coming from a paper. So this is not really from research. This is just an idea, engineering idea. And for the source for this, it's coming from this paper. So when it comes to function calling, I have my own opinion about which benchmark that is really interesting here. And here, the order of creation was really interesting because each one of these was created because the previous part was saturated. So version 1, which came in February 2024, introduced abstract syntax trees as an evaluation metric. And after that, you had version 2, which added enterprise and community contributed functions. So this was in August 2024. Also, it added the relevance detection. Version 3 added multi-turn judged on state. Version 4, which was in July 2025, went holistic and agentic, had web search, memory, format sensitivity. If you look at this, like at the scoring, it's actually weighted. You have 40%, which is agentic, 30 on the multi-turn, 10% here, and 20 here. So we are basically saying that we have 70% on agentic plus multi-turn because single call accuracy has stopped being interesting here. Everyone is near the ceiling there. If someone, and this is something very important, if someone quotes you a function calling score, ask, of course, on which bucket, because yeah, that makes a big difference. And when it comes to rankings, so this is from August 2026. Our video is from 25th of August 2026. And the scores are really close to each other. They are all at around 76.7, let's say. Here, so the difference between GLM, Claude, Opus, and Gemini is not that big. So there isn't really a real clear number one when it comes to function calling. So what's actually going wrong? The cleanest published taxonomy gives 7 recurring error types. You have insufficient API calls, incorrect argument values, incorrect argument names, and so on and so forth. And 3 of these actually are about invalid output formatting, and 7 of these are about arguments specifically. So 3 are about invalid output, and 7 are about arguments specifically. And that is the consistent finding from a course paper called ToolScan. And the idea was that the largest argument errors are the largest failure class, bigger than picking the wrong tool. Note here that I said largest class, not a percentage. I didn't cite a percentage. It's because you see different numbers from different sources, and to be honest, the discrepancy between the numbers was so big that I can't come to you and tell you that I can cite one number, but just there is certain pattern, which is that argument errors are the most consistent failure class. So what is measurable And here again, the spread between models is quite enormous. On one benchmark, one model produced extra parameters on nearly 35% of calls. So this was ChatGPT 5.1. Actually, I personally remember trying it, and it was pretty bad, if I remember really well. Like 5.1 was not great. Also, another produced extra parameters on 4.4%, which was much better, and there was also wrong values at 8.2. Here, the issue is that there is a huge spread. There is also the issue of benchmarks. Like, what did they get tested to, and could we trust these results? And here, I can just give you general patterns and general vibe, let's say. And I would say that there are three kinds of argument errors: missing, extra, and the nasty one, which is the worst one, wrong value. So generally, stay away from whatever model. Like, the other ones could be salvageable in production, but the wrong value one will really create the worst problems when it comes to your dataset, to your if you're deploying enterprise AI. And yeah, and that's the main idea. So actually, the example that we started with was actually a measured example, and the score of our model improved from 36 to 78% by just rewriting the tool that the model was using on the same task, the task of reading and sending your description with input schema, the same first task that we presented in the beginning. And actually, there was actually another paper that was discussing the same issue. So the interface, like, let's say you have multiple tools. So let's start with the first line here. You had near duplicates available for your model. So the same tool, you swap in tools that look alike, and your model, if it confuses these tools, would have its accuracy drop from 94.50% to about 70%. And the other issue was going from 10 tools to 100 plus tools in the catalog available to your model would drop the accuracy by a lot, from 78 to about 14%. So the first one implies that random unrelated distractors barely hurt at all. They do hurt. It's considerable here. But the bigger one is the confusability. So which means that the fix for our engineering, for enterprise AI, is interface engineering, not a smarter model. So giving Claude a search over tools instead of stuffing all of them into context would actually improve the accuracy much more than, like, reducing your catalog and being precise about what you're offering your model would really increase your accuracy instead of just stuffing the whole thing in. And to be clear, calling solved and interfacing solved is here my own framing. It's not coming from a paper. It's just a thought that I was having. So we're almost in the end, and here I want to mention a couple of things so that you don't get confused. First, function calling is not the loop here. So function calling is the mechanism inside one step. The loop is the repetition around it, with observations, of course, between steps. One tool call is not an agent. So that's the first thing. Second thing, it's not MCP. So, and this is something you will be asked about in meetings and in interviews or whatever. The cleanest statement that I can here differentiate between MCP and tool call would be MCP, for example, function calling is how the model expresses what it wants to do. MCP is the infrastructure that makes those requests portable. Portable, discoverable, executable across different systems. So basically, one is the model capability, the other is a distribution standard built on it. And actually, the next video will be about MCPs, so you will get the nuances there much better when you're watching the next video. Third, it's not just structured output. So structured output constrains the shape of an answer. So it's not just about that. Function calling selects an action and builds arguments intended to be executed. So second one here has consequences in the world. This one is basically formatting. Fourth, it's not correct because it's validated. So there is difference between well-formedness and correctness. Well-formedness is, okay, it's following the structured output format. So that's well-formedness. Correctness is really, it's correct. The data is correct. And there lies a very huge difference. So finally, to recap the whole episode, you have three things to carry. One, the model never acts. It's basically emitting a request and you execute it, which means every control you have, tool choice, parallelism, validation, lives on our side of the line. So we are doing that decision. Two, strict mode is syntax only. The grammar guarantees the call parses. Nothing guarantees the values are right. Three, the interface is the product. Name, description, schema are the only tokens the model ever sees. And rewriting them alone took one team from 36 to 78%. We have three design rules which fall straight out of that. First, leave tool choice on auto unless you can promise a tool applies in your case, in your task. Let the model reason first and emit the call last. Also parallelize reads, serialize writes. This one is basically the whole series. It's the most important one. Next episode will be about MCPs. It will be also really important and it will be the final episode in the series. So basically MCPs are about what happens when those three strings stop living in your codebase and start being served by somebody else. So see you in the next episode. If you like the content, please like and subscribe and follow me on LinkedIn. See you.